All right, howdy. My name is Evan Pettit,
And I'm Alex Kishko.
and this is our extra credit report on photoplethysmography. So what is photoplethysmography, otherwise commonly known as PPG? So photoplethysmography is a non-invasive optical sensing technique used to capture real-time medical information about a patient. Now, most standard PPGs use red and infrared light sources coupled with corresponding photodiodes to capture the physiological signal, where it can then be filtered and amplified, typically using a variation of an op-amp circuit or several put in series. Now, the physiological origins of a PPG signal. PPG works by detecting changes in arterial blood volume using LED and photodiode combo circuit mentioned above. So the sensor is placed on the skin, typically above and below a finger, although other sites are used like on the earlobe or on the forehead, and red and IR light are emitted from the LEDs. This light passes through the body where it's absorbed by the surrounding tissue and blood, with the photodiode measuring the intensity of the remaining light after it is transmitted through the body. It works as the amount of blood within an artery increases, the more light is absorbed from the LED, which means there's a decrease in intensity read by the photodiode and vice versa. So the strength of the signal will vary based on the arterial blood flow within like your finger, for instance.
So essentially, why are photoplethysmography signals important? It allows for easy, non-invasive monitoring of the cardiovascular system, which include values as oxygen saturation, heart rate, blood pressure, and cardiac output. And then all of these other signals can be derived from the PPG signal. And then PPG signals are also very effective at differentiating between small irregularities of the pulse. This allows for cheap, rapid detection and diagnosis of major arterial and ventricle defects in a patient very quickly and easily without having to go through other invasive methods such as surgery. And then what impact does photoplethysmography have on patient health? So due to its non-invasive nature, it allows for low cost and portable options for patient monitoring, which is extremely useful in third world or developing countries. And then with the simple nature of photoplethysmography, this allows for a constant monitoring of the patient's cardiovascular signals, which constant monitoring allows for the gradual changes in patient health to be easily more found and then therefore treated and diagnosed.
So about the circuitry of a PPG device, so they can vary in complexity depending on how precise a waveform is required as an output. For instance, in our bioinstrumentation class, we designed a very, very simple PPG sensing circuit, which involved an LM741 op-amp and a red LED and a photodiode, where essentially you would clip it onto your finger and measure the current that's coming through the photodiode, obviously being detected from the LED source. And then that circuit to the right with the op-amp is actually a current to voltage converter. So it can actually be fed through the op-amp, converted to a voltage source, and read through an ADC to actually produce the wanted waveform. Now, a more complex version of the PPG circuitry, as you can see here, does essentially the same thing, except it has a couple more components, which include an inverter and a low-pass filter, two low-pass filters actually, a transimpedance amplifier, and a DC subtraction variable gain amplifier. And essentially all of these do is make the signal less noisy and allow it to be read easier, so where you can pick out the physiological signals being produced by the PPG sensor. And here are our works cited, and thank you for listening.